talk about section 12.3, beginning on page 810. And we're going to talk about geometric sequences today. What makes a sequence geometric is that now we multiply by the same number every time to get the next term. And that same number that we multiply by is called the common ratio. So remember, it was the common difference when we were adding every time. It's a common ratio when we multiply every time. Why was it a common difference when we add? Well, because remember, we found it by going backwards, which meant we subtracted, right? Difference means subtract. Well, if we're multiplying every time, what's the opposite or the inverse of multiplying? Dividing. And how are ratios written? As a division problem, right? A fraction, 2 over 5, that kind of thing. So it turns out that the common ratio, which we call R, is always equal to any term divided by the previous term. So for example, we may have something that looks like 1, 2, 4, 8, 16, 32, ... That's an example of a geometric sequence. Why is it a sequence? The commas, right? So it's a sequence because of the commas. Why is it geometric? Well, what are we multiplying by every time? 2. So R is equal to 2. How do we find R? We take any term and divide it by the previous one. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 4 is 2, etc. Everybody got that? Now, it's very important that you know to do it that way, because sometimes you'll have fractions in the problem, and it won't be so obvious when you're looking at it what the ratio is. So you want to set it up and simplify it to figure out what R is. You don't want to guess at it. Okay? So for example, if you had two terms, let's say we had, dot, 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 and then we had something, and we had 2/3, comma, 5 over 6, dot, dot, dot. What would the R be here? Well, you would take any term divided by the term before it. Well, we don't divide by fractions. What do? Multiply by the reciprocal. You guys are so good. So our R would be 5 over 4. Would you guess from looking at that you were multiplying by 5 over 4? Yeah. You guys couldn't even say that with a straight face. You guys who still tell me that 1/2 plus 1/2 is 1/4, right? You're going to tell me that you would recognize 5 over 4 there. That was good, though. Your timing was very good. I'll give you that. Your comedic timing was right on. Everybody see how to do that to find R? It's very simple. Now, the general formula, this is the third of our formulas that we have to memorize. Remember, I told you that just like we have an A sub n and an S sub n formula for arithmetic, we're going to have an A sub n and an S sub n formula for geometric. For geometric, the A sub n formula is A1 times R to the n minus 1 power. It's actually a much simpler formula to work with than the A sub n for arithmetic. There's less to it. So if we have our 1, 2, 4, 8, 16, etc., A sub n is equal to the first term 1 times our R, which we know is 2, to the n minus 1 power. And so this would just be an equals 2 to the n minus 1. So if we want to find the 1, 2, 3, 4, 5th term, we plug in 5 for n. 5 minus 1 is 4. 2 to the 4th is 16. It works. Now, why is it n minus 1? It's because the n minus 1 is telling you how many steps you took, how many times you had to multiply by r. If you multiply by r, and then r, and then r, and then r, that's r to the 4th power. That gets you from the first term to the 5th term. 4 steps. Okay, does that make sense to everybody? Let's take a look at another one. So we want to write the rule for the nth term, and then we want to find the 7th term, let's say. So we want to know what a sub n is equal to, and we want to know what a sub 7 is equal to. What's r here? 5. 500 divided by 100 is 5. 20 divided by 4 is 5. So an is equal to a1 times r to the n minus 1 power. Is that the same thing as 20 to the n minus 1? No. What is attached to the n minus 1 power? The 5. But if I multiply 5 times 4, aren't I then raising the 4 to that power also? Is that what the original problem said? No. What power does 4 get raised to? Just the first power, right? So don't attach that n minus 1 power to it. We have to do exponents before we multiply, PEMDAS, right? Please excuse my dear Aunt Sally, order of operations, you have to do exponents first. So you just write it like this, or you can write it like this without the dot. Either of those is fine. Yes?
Oh, wait, never mind. Okay. I thought I was laughing. But, yeah,
You okay? Okay. So how do we find a sub 7? That's 4 times 5 to the 6th power. So that's going to be 4 times, what's 5 to the 6th power? 15,625 is right. So that's what, 62,000, what is it? 62,500. Questions about that, guys? So does everybody see how easy that is to work with? Now, there is the slightly more complicated version, or versions. So what if they ask you to find the rule if r is equal to 2 and a sub 4 is equal to 12? Well, we know that an is equal to a1 times r to the n minus 1. So we know that a sub 4 is equal to the first term times r, which is 2, to the 4 minus 1 power. But I just plug in what they gave me. What is a sub 4 equal to, though? 12 is equal to the first term times 2 to the 3rd power, which is what? So a sub 1 then is equal to 12 over 8, which is equal to what? 4/3. And so that means that this is really an is equal to the first term. Sorry? Thank you. I was wondering if you guys were going to catch that before I got to the end. So 3 over 2 times 2 to the n minus 1. You caught that before I got a chance to go back and remind you guys that, you told me that you got the 5 over 4 in your head, right? Questions about that? That's good. As long as you caught it before I got to it, I won't give you too much trouble. Everybody good with that example? Now, we also have the slightly more complicated version, which is this, and then I'll get you going on the assignment. A sub 3 equals negative 48. A sub 6 equals 3,072. We want to find a sub n, the rule. Well, we do this the same way that we do the ones with arithmetic. How many steps do we take from 3 to 6? What are we doing at every step? Multiplying by? Well, we don't know what number, but in general, what are we multiplying by? R. So if we multiply by R, and then R, and then R, that's really multiplying by what? Not 3R. R cubed. What are we multiplying by altogether to get from negative 48 to 3072? How can we figure that out? Yeah, divide. Go backwards. What's 3,072 divided by negative 48? What is it? Negative 64, right? It's negative 64. So when you guys do 3072 going backwards, you're going to divide by negative 48. It's going to give you negative 64. So we know that r cubed must give us negative 64. So what must r be then? So we now know that a sub n is equal to a1 times negative 4 to the n minus 1. How are we going to find a1? What did we do on the arithmetic version to find the first term? Plugged in one of our points. So plug in one of your values. So a sub 3 is equal to a1 times negative 4 to the 3 minus 1. A sub 3 is really what? Equals a1 times negative 4 squared is 16. Divide both sides by 16. And you get a1 equals negative 3. So your final answer is an equals a1 times r to the n minus 1. So do you see it's the same type of thing? We're just working with a slightly different formula. But it's actually an easier formula to work with. Now the good news is the sequences are a little bit easier of a formula to work with. The bad news is that the series are worse to work with. But we'll use our calculator to help us do them as decimals and things so we don't have to worry about all kinds of crazy common denominators. We'll do that tomorrow. Any questions about that? Great. The homework assignment then.